Good morning, ladies and gentlemen. Hope you guys are doing well, and just wanted to produce a follow-up video for you guys because at the end of video 1.4, I ended with this question and I did not go through how to solve it. I think it'd be important if I walked you through what that looks like, considering I don't think this is a type of question or a skill that you've had to use before. And so I wanted to do this video as a follow-up to give you guys some guidance so you could know what to do if you were faced with a problem like this as well. And so if you recall from the PowerPoint, the very last slide, it gave us this question. It said an impure sample of SO3 contains 40% oxygen. What is the percent of SO3, sulfur trioxide, in the sample? Now, you may be reading that question and you may be thinking to yourself, Mr. Kenton, how in the heck do I do this? I don't even know what this question is asking. How am I going to do this? And so I'm going to walk you through it. So some things that I want to draw your attention to of how I'm going to approach this question. The first thing that I notice is that it tells me that the sample is impure. Okay, so in this sample, it's not all SO3. In fact, it tells me that there's a certain percentage of oxygen in this impure sample, that 40%. Okay, that's going to be an important piece of information that we're going to need in order to solve this particular problem. Now, ultimately, they want to know what is the percent of SO3 in this sample. And so in order to solve this, my first task is going to be determining the percent oxygen in SO3, okay? And so if you remember, in order to do percent composition, what we have to do is say, all right, the percent of oxygen is going to be equal to the number of oxygen atoms we have in the compound, which in this case is 3, times the molar mass of that substance, which is 16, divided by the total mass of our compound. And so if you look at the periodic table, sulfur has a mass of 32.07, oxygen has a mass of 16, and so if you combine those, we're going to get that the total mass of SO3 is 80.07 grams. Okay. Now, when I do all this, of course, we want this to be a percentage, so I'd have to multiply that all by 100. But when we do that, we get that the percentage of oxygen in SO3, if it's a pure sample, if it's 100% SO3, would be 59.95% oxygen. Now, I chose 4 significant digits because my molar masses all went to 4 significant digits, okay? So that's why I made it 59.95. Now, that is the percent oxygen that's in a pure sample of SO3. But notice we have an impure sample, and the percent oxygen is 40%. And so now to determine what percentage of this impure sample is sulfur trioxide, what we're going to need to do is we're going to need to take the percent oxygen of the impure sample, so we've got 40%, and we're going to divide that by the percentage in the pure sample of SO3, which is that 59.95% that we calculated. Now we multiply that by 100 as well, because that'll give us the percentage of SO3. And so when you divide that, since it's essentially 40 divided by 60, we find that this particular impure sample is 67% SO3. Okay, so in this impure sample, it contains 67% SO3, and the other percentage is some impurity, which is causing the oxygen percent composition to go down. I hope that makes sense. I hope that gives you some clarity and maybe clears up any confusion that you have as it pertains to this particular question. If you do have any more questions as it pertains to this particular topic, please let me know. You can email me, you can hop on Google Meet, and we can talk through it during office hours. But I wanted to get this out for you guys as a follow-up, and I hope that this helps you as you go forward. Thank you guys so much.